Section 7.3, more multiplication properties. So we're going to look at even more additional exponent multiplication properties besides what we saw in 7.2. So here we have raising a power to a power. So to raise a power to a power, we want to multiply exponents. And this occurs when you have an exponential expression in parentheses that is then raised to another exponent. And when you have something raised to an exponent, or an exponential expression raised to an additional exponent, you'll multiply the exponents together. So like this example here, we've got 5 to the 4th power raised to the 2nd power. So that means you're going to multiply the 4 and the 2 to get 5 to the 8th. So let's look at simplifying some problems involving raising a power to a power. So here we're going to take the 4 and we're going to multiply by 7. So that gives us n to the 28th power. And that's our answer. So we're just multiplying it. In question 2, we have p to the 5th raised to the 4th power. So that means we're going to multiply this. Since the parentheses are there and we have an additional power, we'll get p to the 5 times 4 power, which in this case is going to be p to the 20th power. And then in 3, we've got x to the 3/4 power raised to the 1/2 power. So in this case, we're going to multiply our exponents. So x, we have 3/4 times 1/2. Well, with fractions, you multiply straight across. So you should get x to equal, or not x to equal, you're going to get x raised to the 3/8 power. And so that's your answer. So this time we're going to mix in a few of the other properties we have as well, including negative exponents and then just multiplying exponents with the same base. So the first thing we want to do is simplify anytime you have a power to a power. So in question 1, we have x squared times x to the 5th raised to the negative 3rd power. We're going to simplify this part of the problem first, because we know that we should be multiplying the exponents here. So the x squared will wait, and then we've got 5 times negative 3 gives us x to the negative 15th. Now we're multiplying two items with the same base. So now at this point it becomes an addition problem. So 2 plus negative 15, which is going to give us x to the negative 13th power. And so the last thing we need to do is we don't want negative exponents, so we put the x to the 13th underneath so it's positive. And that's our final answer. As you become more comfortable with this process, you can kind of skip steps here and there, but for right now, let's try to write out all our steps. So in question 2, we've got w to the negative 2nd times w to the 5/3 power raised to the 3rd power. So we're going to simplify this part first. All right, so 5/3 times 3 is just 5. So we've got w to the negative 2nd times w to the 5th power. So now we're going to use addition. So negative 2 plus 5 gives us w to the 3rd power. And that is our final answer. Question 3, same idea. We're going to simplify first the power to a power piece. So we're going to multiply s to the 4th and s to the 6th, or s to the 4th raised to the 6th power, which is s to the 24th. And then we've got s to the negative 5th being multiplied by that. Now we have two powers with the same bases, so we add their exponents. So negative 5 plus 24 gives us our final answer of s to the 19th power. So raising a product to a power. To raise a product to a power, you raise each factor to the power and multiply. So same idea, you're still taking parentheses and you have a power outside of it. So you're raising or you're multiplying all the exponents inside by that power, but you're also applying that exponent to maybe the coefficients out in front as well. So it's just a matter of circumstance. Depends on what's inside your parentheses, but everything's getting that exponent applied to it. So this example here, 3x to the 4th, the 4 outside is going to get multiplied by the 1 that's attached to the x, but it's also going to get applied to the 3 as well. So you're distributing that exponent within. So first example, we have 3x to the 5th raised to the 3rd power. So that means we're going to get 3 to the 3rd, because it's going to go to each of these. And then we've got x to the 5 times 3, which 5 times 3 is 15. All right, so we know that we have x to the 15th power here, and then 3 to the 3rd power is 27. So our final answer is 27x to the 15th power. Question 2, we'll do the same thing. We're going to go ahead and distribute this throughout. So you've got 2 to the negative 4th power and z to the negative 4th power. In both cases, I want to drop these underneath the fraction bar to get rid of the negative exponents. So 2 to the 4th, z to the 4th. But I can simplify 2 to the 4th power as 16. So my final answer is 1 over 16 z to the 4th. Question 3, what is the area of a square? Well, keep in mind the area of a square is just side times side, since all the sides are the same, or side squared in this case. And they tell you that the side here is 5x to the 3rd. So really what they're having you do is they want to know what is 5x to the 3rd squared. Well, we know how to do this. We're going to distribute this to both items inside. So you've got 5 squared, and then x, whatever 3 times 2 is, which would be 6. So you end up with 25x to the 6th power. That's your answer. Question 1, we're simplifying an expression with products. All right, so the first thing we want to do is apply a power to a power, which means in question 1, we're going to apply this to that. So we've got 3 to the 3rd, and then 2 times 3 is 6. And then here we apply this power, so 2 times 4 is 8, so c to the 8th. Now we can go ahead and simplify any multiplication or add any powers with like bases. So 3 to the 3rd power is 27, so I can simplify that. And then I know I need to add the 6 and the 8 together because they have the same base, so it's c to the 14th. Question 2, same idea. So 2 times negative 2 here for x squared raised to the negative 2nd power gives us x to the negative 4th. And then 3x y to the 5th raised to the 4th power. This 4 is going to get applied to all items here. So that's 3 to the 4th, x to the 4th, and y to the 20th. So at this point, we can go ahead and add any like-based items exponents. And then if we need to, we'll go ahead and multiply out the 3. So 3 to the 4th gives us 81. We've got x, where it's negative 4 plus positive 4, which is going to be 0. And then y to the 20th. So when we simplify this down, x to the 0 power is just 1, so we end up with 81 y to the 20th. Same idea in 3. We're going to go ahead and apply this to everything inside the parentheses. So 2 to the 3rd, a to the 3rd, and b to the 3rd. And then we apply the 2. So we've got 5 squared and a to the negative 6th. So 2 cubed is 8. And then 5 squared is 25. And so at this point, I can go ahead and start trying to combine the exponents with like bases. So I'll add their exponents together. But I also have coefficients to deal with now. So I'm going to multiply the coefficients of 8 and 25 together. And then a to the 3rd and a to the negative 6. Well, that's 3 plus negative 6. And then I've just got 1b to the 3rd. So 8 times 25 is 200. A to the negative 3rd power, b to the 3rd. But I don't want negative exponents, so I've got to move this. So that means I'll drop the a underneath. So I end up with 200 b to the 3rd over a to the 3rd. And that's my answer. Question 4, same idea. We'll kind of speed this up. So the 6 gets applied to both. So 2 to the 6th, b to the 2nd. Then you've got ab to the negative 1/2 power, so you apply the 4 to both items, so a to the 4th, b to the negative 2nd. All right, so 2 to the 6th power is 64. We've got b to the 2nd plus b to the negative 2nd, and then a to the 4th. Well, 2 plus negative 2 is 0, which means that this b here is b to the 0 power, which means it's just 1. So our final answer should just be 64 a to the 4th. Question 5, we've got z to the negative 3rd raised to the negative 2nd power times 7y to the negative 1st z to the 3rd raised to the 2nd power. So we're going to kind of distribute these exponents. So we've got z to the 6th, negative 3 times negative 2 is 6. We've got 7 squared, negative 1 times 2 is negative 2, and then z, 3 times 2 is 6, so z to the 6th. And so now we want to kind of simplify it. Well, 7 squared is 49. We will add the exponents on the z's, so 6 plus 6 is 12. And then y to the negative 2nd, we want to move that underneath because we don't want negative exponents. So our final answer is 49 z to the 12th over y squared. Question 6, same idea. Distribute the 4 to both the t and the 2. So you've got 2 to the 4th, and then t to the 2nd power. 1/2 times 4 is 2. Then you can distribute the 0, but anything times 0 is just 0. So this is actually just going to become 1. So right now we're just trying to simplify 2 to the 4th times t squared. Well, 2 to the 4th is 16. And then the t squared stays, so you end up with a final answer of 16 t squared.